And we'll be looking at this in just a minute.
81 or 88?
81.
What's this called? Estimating slope. Should, and when you log in, it should like pop up a thing.
Just asking me to set it. Yeah.
I didn't get it from their Steve.
What? Jason. Yeah. We'll just ask you.
I know. Go to sleep again.
I had a red my face, like my hand.
Really?
It was really embarrassing.
We almost deleted it. Almost.
It's like, you guys got with it. So I was like, out. She's, how was that? She said she started like talking to me.
Yeah, she did. Like she was talking regular stuff.
Okay, now on those regarding the handouts.
Can you resend that file?
A
couple of us didn't get it.
You sure?
Yeah.
That's weird.
It's in the
Oh shoot! Yeah. Okay. Look in the press to test folder. Yeah, I think I did forget to. Yeah, I did forget to change the folder. Okay, so yeah, look in the press to test folder. Now regarding the handouts, the Lion and the Ranger, something you should do at your convenience. Okay, it's not due on Monday or anything, but we will be talking about it another time. All right, and I'll try to remind you at some point along the way, hey, we're going to be doing this. You should, spend some time on it and so forth. But it does have some direction. For those of you that did get far enough to get to the back page, my directions about graphing a parametric equation are a little bit off when it says press menu. Matter of fact, go ahead and press menu there, Nolan. Oh wait, we're in the wrong place. Go to hit your scratch pad. Yeah, and then from the now hit menu. And in my directions, it says go under graph type. Well, that was in the previous operating system. In the new update, they've changed it to graph entry / edit. And so when you go to that, then one of the choices there is parametric. Don't choose it now. But, so that's, it says graph type, but they've changed the wording of that menu item a little bit. And then, of course, today you will need this, the Chapter 2 assignment sheet, homework sheet, okay? So let's go ahead now. Again, the quizzes will get graded this weekend, and I'll have those scores up on the website on PowerSchool Sunday, sometime later in the day, probably. We won't probably look at them yet. There's still a few people be finishing them up or taking them on Monday. So we'll just go ahead and jump right in here and get done with this, and leave you hopefully a fair amount of time to work on homework here today. So what we're going to be doing in Chapter 2 is we're going to now take what we've learned, all these connections about f and f prime and f double prime and slope and rate of change and all that, and really get more technical with it, really get more, symbolic, as it says right there. The title of this book is Calculus from Graphical, Numerical, and Symbolic Points of View. Well, we've studied the derivative mostly graphically. Here's an f prime graph, tell about f, and f double prime, and so forth. It's nice because it's visual, and a lot of people can understand things visually that way. When I took calculus, and when I first started teaching calculus 15 years ago, we didn't do much with graphs. It was very much symbolic, very much with equations. Now, if you like algebra and factoring and that kind of stuff, then you'll love the stuff we're getting into next, right? Because it's more of that kind of stuff. And a lot of you are probably good at that, right? In my day, it was almost all that. We worked with graphs very little. What we did with graphs is we had to graph it by hand a lot because we didn't have graphing calculator. And so we spent a lot of time plotting points and plugging in numbers, and if I had to graph a cubic equation, you know, you had to plot a lot of points. Matter of fact, that's one of the big things we used to do in calculus that we don't anymore. You know, this whole thing about max and mins and inflection points, we would use the calculus that we're going to be learning here coming up about equations to help us find the max and the min and the inflection points, and then we would plug those numbers into the function and plot them, and we could draw pretty accurate, nice, smooth graphs once we knew all those important points. But we kind of quit doing the graphing part of it because now that we got these, why spend so much time plotting points when you can plug it into here and get a nice graph? The reason we wanted to plot the graphs anyway is so we could look at them and analyze them. So if we can just get them quickly, the most important point is the analysis of the graphs anyway. So that's why we've done it the way we've done it now in this book, and I really like how this book approaches it. But we do want to get into the symbolic use. It's still important. It's just that we used to do this 95% of the time, and now it's, you know, we're a little more balanced in our approach and how we do it. We look at it from all the various ways. Okay, so what we want to do is, and like you guys have already pointed out, you guys know that, I mean, you guys are the ones that told me the other day that if we have a x cubed minus 2x plus 3, if I have a cubic function for f, what's f prime going to look like? It's going to be something squared, right? It's going to be something with an x squared. It seems like the power decreases by 1. So what we're going to be investigating, matter of fact, we're going to find out on Monday. So, you know, again, kind of suspense for weekend, you know, just wondering what's in store. But we're going to find out on Monday just exactly what quadratic f prime will be. Okay, just exactly what the equation of f prime is from f. Okay, and we're going to see how that comes about. All right, so that's where we're going with this. And so we're going to do a lot more work with equations of functions, you know, than graphs and so forth. All right, because we've done a lot of work with those already. All right, so let's run through this. So some of this that we do today is going to sound very familiar, stuff we've been talking about a lot. All right, so let's go to the next page here, Nolan. And, okay, we're going to draw a secant that intersects the graph x squared. What happens to the slope as we move point Q towards point P? So we go to the next page. And so if Nolan, what we have there is, and you guys can follow along on yours. So as we get what we have here are 2 points. That's called a secant line because it crosses twice, that dashed line. And what we're going to do is what we're looking for is what's the slope of the parabola at 1. That's what we're interested in right here. And so we're looking for f prime of 1 is what we're looking for, right? The slope at 1. Well, we can't do slope at 2 points, or at 1 point. We need 2 points. So now, when we did this in the early stages, we picked a point on both sides, right? We said, let's pick a point on both sides and let those two get closer and closer. Well, here's the thing. If he drags this point down here and gets really, really close, won't it get really close to the tangent line? We don't really need a point on both sides, and it makes the algebra easier. So what we're going to, instead of moving 2 points, okay, and getting them closer and closer, we're just going to leave this as one of the points and then have a point to the right, because that's the positive direction. So again, it makes the algebra easier. So we're going to pick our second point to the right, and then we're going to let that point get closer and closer to that one. So go ahead and drag it down there, Nolan. And so what you see is that tangent line, click and hold until that fist closes. There you go. Now you can drag. Okay? So now as we drag that point, that dotted line, that secant line, is getting closer and closer to being a tangent line. Okay? And the slope of that tangent line is going to be the derivative, the slope at 1. Okay, go ahead and drag it back then. But that's the idea. So we're letting 2 points become 1, right? And the secant line becomes a tangent line, which is the derivative. All right? Again, not new. We've talked about that a lot. Okay, go to the next page. And on the next page, we have basically the same scenario. Difference is here we've got the actual slope here. Okay? And if you grab that point, let's do the same thing again. Let's grab that point and let's slide it down. And of course, we see, you know, that it's getting closer and closer. Okay, drag it back up. Drag it back up. And so we get the overall concept, what we're trying to do, 2 points become 1. We're trying to do the slope at 1. what I want to do is actually do some slope calculations here. Oh, and by the way, this slope here, 3.275, is that more or less than the slope we're going to find here at 1? It's more, right? Because it's steeper. You guys saw that as you dragged that down. This number was getting smaller and smaller, okay? It was approaching something, right? It was getting closer and closer to something that would be the slope we're looking for. But we want to actually do some slope calculations. So we could, by hand here, we could do this slope calculation, right? Like right now, I could take and do the slope calculation. Okay, I could do right now. Okay, I could do 5.18 minus 1 and 2.28 minus 1, and then I would get, that, right? And so what I would like to do is do a bunch of slope calculations as we get closer and closer and closer. But we're going to let the power of the calculator work for us here a little bit. So go to the next page real quick. And on the next page we have a spreadsheet. And what we're going to do, see it says capture here? What we're going to do is back on that other screen, we're going to capture the points as we drag. And then we're going to set up in this third column, we're going to set up a formula to do the slope for us, so it'll be much quicker. Okay? And let the spreadsheet do the calculation. So go back a page. Okay? All right. And see down here with the decimal point, see it says capture in blue. So how do we get the blue? Control. So right now, hit Control decimal point, Control capture. Now, go to the next page real quick, just so you can see what happened. Okay, it grabbed that point and it stuck it in our spreadsheet. Okay, so go back a page. All right, now drag it down just a little ways and then capture again, Control period. Okay, and everybody else can do this. You don't have to do it, but whatever. Okay, Control period, right? Capture. Drag it a little farther. Control period. A little more, and keep going, and let's get several points down there close. Let's be sure to capture a couple of them down close, because we do want the 2 points to get really close, right? I mean, that's the key thing. So let's go down there and get several really close in. It's kind of hard. It's hard physically to drag these and get them really close. So we're limited there a little bit. Okay, see if we can get one. All right, go ahead and go to the next page then. So we've gathered a number of points. Now, go over and arrow over here into this cell. Okay? Now, over in this cell, we want to do a slope formula. And we want to do the slope between this point and the point 1, 1. So what would my slope formula look like? First of all, we've got to hit an equal sign. We're in a spreadsheet. So if we're going to do a formula spreadsheet, we've got to do that. And then hit Control Divide, because we want a fraction, or slope, right? Okay, so now what do I want to do? I want to take this point minus 1, right? But now I want to do that for all the points. So I don't want to type 5.1. I want to type what? I want to type B1, right? Now I think you can just type B1, or you can click on that cell, either way. So B1 minus 1, I think they said in the art class at work to just type B1. And then what's this going to be? A1 minus 1. And then hit Enter. And there we go. There's our slope. Now we arrow up to that. Now we want to fill this down. I think we did this one other time. So we'll go to the menu and Data and Fill. And then we can just go over there and arrow down. Okay. And hit Enter. All right, arrow back up. Okay, and then just scroll down. And what do you notice? The slopes are getting less, like we expected. And they're getting closer to what? If you had to make a guess, 2. Now, the slopes aren't always going to come out that nice and neat, but this is a simple parabola, and we're at the nice point 1, 1. So it seems like that a reasonable guess would be the slope is 2. Okay, go to the next page. And so what we could have done, and again, all this with spreadsheets kind of fun. I think it's kind of cool. The calculator kind of fancy. It's kind of neat to see it capture those points and do all that. So I like doing that. But we could, if we really just wanted that slope at 1, we could have just done a slope calculation right here. So what they've already done, they've already defined f1 to be our x squared. So let's do a little slope calculation right here using function notation. So, and let's put this way, we instead of dragging, we can't get very close. What would be a point pretty darn close to 1, but on the right? 1.001, right? 1.001. So how would we type it here? Hit Control Divide first. Oops, delete that, my fault. We want to arrow down and get down here. This is a calculator box down here. There we go. There we go. Well, let's get down there. So what would I do to get the y value at 1.001? What can I type right here? Careful, F1 of, okay, so let's do that. F1 of 1 point, let's do 2 zeros, yeah. Let's do F1 of 1.001, then what? Minus, no, I don't want to go on two sides now. F1 of 1. I want 1 to be our 1 point, and then I want a point just really close to the right of it. Okay? Again, just because the algebra, as we get into this, could be, and it doesn't matter. Would it be a little more accurate to have 1 on both sides? Yeah, but if we get it close enough, they're both going to be accurate enough. All right? And then the bottom will be 1. Right now, that just should really be automatic to you. When I say the slope formula, and I don't want you thinking y2 minus y1 anymore. That's kid stuff, right? That's algebra 1, right? We think f of b minus f of a over b minus a. We think f1 of 1.01 minus f1 of 1. That's what we think of when we do slope. Okay, hit enter. So we could find the slope just right there without having to go through all that graphical stuff and everything. We can just do it right there. Okay, and surely we're fairly convinced now that the slope is 2. Getting closer and closer, isn't it? All right, so we've been doing all this estimating and sketching tangent lines and picking 2 points really close together. Now we want to get more exact. We want the slope at 1 exactly. We want to find that it is exactly 2. Okay, in that case, and we're going to do a different example today. But, okay, so, but there it is. All right, that one is really close. We can tell it's going to be 2, but what would that look like? So we're going to take this same approach to write ourselves a little formula here. So I'm going to switch to this picture. So in your notes, draw a picture kind of like this right here. Draw a picture like this, and we want to find the slope at A. All right? There's the point A, f of A. They label it point P. All right, I'm going to have to kind of shift back and forth here, but all right, sorry, step back for you. All right, everybody got something kind of like that? All right, and what we want to do is we want to find the slope at that point. So we need 2 points, right, to do slope. So we're going to pick a second point, and that point's going to be where? We're going to pick a second point where? To the right, a little ways. Okay, and that second point is going to be, we're going to call it A plus H. Could have called it B, could have called it X, could have called it a lot of things. I'm going to call it A plus H. What's that mean? What's H then? That's that distance. Now, in terms of slope, that's what? In slope language, what's this distance? Come on. In slope language, what's that? The run. Isn't that the run? And the rise is this way, right? The run is this way. So in slope language, right there, H is the run. Rise over run. Okay. So our second point is going to be A plus H. Now we need the Y value at that point. Okay? Well, the Y value at that point is going to be F of A plus H. Would you believe that, right? Instead of F of B, it's F of A plus H. So we got A, F of A, and we got A plus H, F of A plus H. Now, we should take just a moment here to review a little function notation. So over here, this might be off my screen a little bit. So, Okay, so I'm going to go with f of x equals 3x squared minus x. All right? Now, some of you guys saw this on the board earlier. What's f of a then? What's f of a? Isn't it 3a squared minus a? And what's f of t? 3t squared minus t. And what's f of 2? 3 times 2 squared. Right? I mean, this just means take a 2 and put it in where the x is, put a t, put it in where the x is. What's f of German Shorthair? 3 German Shorthair squared minus German Shorthair. Or black lab, since I got a black lab. So anyway, or boxer, yeah, it is more of a boxer. Somebody else said it looked like a toaster this morning. So anyway, whatever. But, okay, now, what's f of 7 plus h? Minus 7 plus h?
Parentheses around 7 plus h.
Awesome. Now, those of you that didn't yell that out right away, I hope at least you had goosebumps or shivers or something. Because that, when I wrote that, that should have just made your skin crawl. I mean, I could hardly do it. It was almost like the chalkboard, nails on the chalkboard or something, just to write it. Right? Fix it, hurry. Is it bothering you? Okay, good. Yes, put them on, hurry. Okay? Yes. Because I promise you, somebody's going to do that in here. And why is that important? Well, it's not up there right now, but earlier we saw that f of a plus h, right? We're going to have that. We're going to have to plug that into functions. And somebody's going to screw that up because you've got to distribute that negative through there. And if you don't have parentheses on that, that messes it all up. Okay? So that should really, really bother you when you go to plug that quantity in for x. You better have it in parentheses. Now, there are times you don't need it. If that was a plus sign in between there, wouldn't have been as big a deal. Okay? But when that minus is in there, man, we screw that up every time. All right? So very careful about that. All right. So that's just a little refresher on this function notation and what we're going to need with it. All right. So back to this. So if I create this line now, this is the same picture we were seeing before. So I've got this line. I now want Q to get closer to P. Well, that means A plus H is going to get closer to A. So what's that mean H is going to do? H is going to get smaller and smaller. H is going to get closer and closer to 0, right? H is going to become almost nothing. And so right here it says let H approach 0. And so what happens is the 2 points get closer and closer, and eventually you get the tangent line. Okay, now if we actually let H be 0, we got a problem. Because when H is 0, we can't do slope anymore, right? It's undefined because you're trying to divide by 0. If you have no run, then when you do rise over run, it's division by 0. That's, of course, the problem with trying to do slope at one point. Instantaneous rate of change is tough. So that's why we've been doing 2 points but really close together. Okay? So that's the idea. So now how can we write this? That's our goal now. Our goal is how can we write this? Well, we want to write slope. Let's write the slope between this. What would it be? If that's what we're going to call it, absolutely. The slope at A is f prime of A, and let's do a slope formula. I'll write it here in a minute, but tell me what it is. Slope formula, we subtract the y. So what would that look like? A plus h minus f of A. Isn't that what's going to go on top? And on the bottom, A plus h minus A. Now what happens there? A plus h minus A. Just get h, right? And that makes sense because we said h is the run, and the slope is rise over run, so it should be that. Okay? So, what does that look like? That's going to look like this, and we're going to call, I'll write that on the board here. So, we've got, this is called the formal or the limit definition of derivative. Now, technically, it's the derivative at a point. On Monday, we're going to talk about the derivative equation for all x. But right now, it's going to be derivative at a point. So like Ryan said, this is the equation or the formula for f prime of a. Okay? So f prime of a equals, not estimates, not approximately. We're not talking about estimating the slope. Now we're talking about finding the exact slope. Now I'm going to leave myself a little gap here after the equal sign. We're going to fill something in there in a minute. So I'm going to leave myself a little gap there. Okay? And now I'm going to do my slope. So what did you say it was? F of a plus h minus f of a all over a plus h minus a. You can write that if you want. A plus h minus a. And then, of course, the a's will disappear and you'll just have h. But this is rise over run. That's just a slope formula right there. But now, the problem is that right there is simply slope between 2 points. Right? That's just average rate of change. Right? That's just slope between 2 points, the point A and the point A plus H. It only becomes 1 point when what happens? When what happens to H? When H becomes 0. Here's the notation we use for that. It's called a limit. L-I-M. I don't know if Mrs. Payne ever got into any of this last year. I don't think regular advanced math class did necessarily. We put in front of that the limit as H approaches 0. That's how we read that. The limit as H approaches 0. Because H can't ever really technically be 0, right? Otherwise, this is undefined. But it can get closer and closer, infinitely close, which is stuff we've been talking about since day one, right? The door opening and how fast is it opening, right? Okay? But this is how we can formally say it. Now, I really want you to understand that in this definition, there are 2 main parts. There's this part, which is the slope between 2 points, and then there's this part that makes the 2 points become 1 point. That is instantaneous rate of change. Alright? So limit is the secret. I mean, the idea of a limit is the key. That's what makes calculus calculus. This is just algebra 1 right here, slope between 2 points. This makes it instantaneous rate of change. Okay? So, cover this up. You got slope between 2 points. You have to put an approximate sign there, right? The slope's approximately whatever those 2 points are. You throw that in there, you've got the exact slope. Okay. Now, how can we then make that calculation? How can we use this formula to actually do a slope calculation? And that's where all the all the algebra comes in. So let's do a couple together, or we'll do one together and let you try one. Promise on the next quiz you will have to do this. So in your book on page 81, they talk about Professor X beginning a trip. She checks out how far she's traveled at various points along the way. Over on page 82, she plots those points, and it seems to make kind of a parabolic shape. And of course, from that data, you could estimate her velocity, right? Velocity would be miles per hour. That'd be the derivative, the rate of change. So along the way, we could pick a couple points. We could do a slope calculation, and we could get her average rate of change, her average velocity. Okay, and so that's what page 82 is about, and page 83 is about. And we talk about zooming in and picking points really close and all that good stuff. All right, we turn over to page 84. Now, I don't want you to look too closely at page 84. All right, but what they do is they say, you know, her data suggests that the function of her trip, we'll use d for distance, the graph, her graph, is actually this equation right here. Okay, so this would be given to you. This is not something you would come up with, so write that down. So this is the function, this is miles, okay, t is hours, d is the miles she had traveled at various times, so we plug a 1 in, that's where she was after 1 hour, and 2 would be where she is at 2 hours, and so forth. And we would like to know what her speed is right at 2 hours. Instantaneous rate of change. So we want d prime of 2. Well, we have a new formula right over there on the board for d prime of 2. Now the difference is instead of f, it's d. So wherever we see f here, we would substitute d. And wherever we see a, we'll substitute the 2. Right? So let's write that. Let's just copy that formula with those substitutions in there. So limit, as h approaches 0, d of 2 plus h minus d of 2 all over h. Correct? Right? Write it in that function notation first to start with. So we're just copying our formula. By the way, this is 2 very important definitions, formulas that we have throughout the year, and this is one of the 2. Really important from a conceptual standpoint. Not that we'll use them a whole lot, but understanding the concept, right? There's 2 basic ideas, derivative and integral, that we will study this year. Here's the definition of the derivative, so obviously it's a big deal. Okay. So let's go to the next step. We want to work this out. We now have an actual formula. We have an actual equation we can plug something into. Instead of a graph, we just estimate the slope and stuff, right? And pick 2 points and all that. So here we go. Now I'm going to use a little color to this. First we got this red thing. Okay? All right. What's d of 2 plus h? And I refer you to the board over there where we did f of 7 plus h. Tell me what to write. 10 times the quantity 2 plus h plus 15 times the quantity 2 plus h. And I forgot a squared on that one. Isn't that the red thing right there? Everybody okay with that? D of 2 plus h means plug 2 plus h in for t right there in the d function. So I plug 2 plus h for t there, and I plug 2 plus h for t there. Right? Okay, now the formula says I got minus d of 2. We'll make that the blue thing. D of 2 is what? Well, we could just get our calculator out or just in our head and just crank that out real quick, but I'm just going to write it out. 10 times 2, you don't have to write it out. I'm not going to check for that. 15 times 2 squared. Kind of misjudged how much room I have. That is the blue part. And I put those colors in just because I find people doing the first one and getting all caught up in d of 2 plus h, and then they forget that there's more to go. All right? They write out the first of it, they don't write out the last of it. And that's really important to get it all. And then, of course, the bottom is just h. All right, give myself a little more room here. So that is going to be equal to, now we got a little algebra to do. Right? Like I said, those of you that like algebra and simplifying and stuff, this will be right up your alley. Okay, so what do we got here? 20 plus 10h plus, okay, now I got two things. First of all, can I distribute that squared? No. Again, skin's crawling, goosebumps, right? If you get 4 plus h squared, no good. Right here, you got to FOIL that. That'll be 4 plus, it'll end up being 4h, right? It'll be 2h and a 2h, outers and inners, plus h squared. And then, and I could have wrote this all out here, but I wanted to kind of save a step here. And then I got the 15 out in front of it, right? So that's going to be what? 60, 60h plus 15h squared, right? So that's all the red part right there. Got to FOIL that, distribute the 15, and distribute that. And now I've got a minus, and what did you guys say that was, 80? 15 times 4 is 60 plus 20, that'd be 80, right? So the blue part is just 80. All over h. All right. Next line. Now, do you have to write the limit out in front every time? Yeah, no, I'm not going to take off points if you don't have that. But I think it's important. I mean, bring it along. I mean, geez, of course it's important. It's a whole difference between average rate of change and instantaneous rate of change. Without the limit, we got nothing. Okay, so it's very important. All right. What happens on top now? Simplify, combine like terms. If you do things right, something nice like that should happen every time. Okay? And 10h and 60h, 70h, plus 15h squared, all over h. Now what? Okay, now there's two ways to think about it. The way most people generally see it is they factor out an h, because we hammer that so much in algebra class with factoring. Or, and this is something that we'll look at, we'll have a lot of problems later in the year where this happens, where we have a single denominator like that. And it seems to make more sense to actually split it up this way. And that's legal too. Now you can never split a denominator, but you can split the numerator over a single denominator. And so you cancel an h there, and you cancel an h there. Either way, and here we cancel that h, right? And so we end up with limit, as h approaches 0, of 70 plus 15h. Correct? All right, now, that is the really nice step. The h canceling was the key to all of it. Because, go back up here, we said technically you can't let h equal 0, right? Because what happens if h is 0? You're divided by 0. You got no run, right? You rise over run. So you can't divide by 0. You can't divide, you can't divide, you can't divide. Bingo, it's gone. The thing that was causing the problem has canceled out. Now can you let h be 0? Absolutely. Now, again, practically, yes, we can put a 0 in for h. Technically, that's not what's happening. What's happening is we're letting h get closer and closer to 0, right? So think about this expression right here as h gets really infinitely small. You've got 70 plus, what's 15 times 0.000000001? 0.0000015, right? So you've got 70 plus 0.0000015. Which is essentially what? 70. And the smaller it gets, the more this is becoming 70. Now, what's great about that is when we were looking at them before, on the calculator, when we would type in 0.00001 and we'd get 2.00001, right? We were kind of guessing, yeah, I'm pretty sure it's going to 2, right? I mean, it sure seems like it makes sense it's getting closer and closer to 2. We weren't really sure. I mean, you were probably convinced. I'm guessing you didn't lose any sleep over it. But here, without a doubt, we can tell that this is going to get closer and closer to 0. So it is for sure equaling 70, or getting closer and closer to 70. So our final answer then is 70. We don't have limit on it anymore now. That is our actual answer. So technically, h doesn't become 0, but for all practical purposes in working the problem, what we say when we get to this point is plug a 0 in for h. That's what we go ahead and just do. All right? We couldn't plug a 0 in for h until that happened. Now we plug a 0 in for h, we get 70. That's our answer, yes.
So when you get rid of the h in the bottom, you can get rid of the limit, basically?
Well, actually, I didn't get rid of a limit in the next one, but once you get rid of the h in the bottom is when you can then do the limit as h goes to 0. You can then plug the 0 in for h, and once you do that, then your answer and the h is done in the problem, and you're good. Now, don't forget, it's so easy to get lost in the weeds of all this algebra that you forget what you just found. What did we just find? Now, in this particular problem, it had a context. It was how fast she was going, right? D was miles, so D prime was miles per hour. So what we just found is her rate of change at 2 hours was 70 miles per hour. But slope, right, it could mean slope as well. That the slope of that graph at 2 is 70. That's what we just found. But not by estimating, not by counting squares, not by picking 2 close points, right? We actually cranked it out and came up with that calculation. The next quiz you will most definitely, and we typically most years call this the long way, because we are going to learn on Monday how to, by going through this process, find some patterns of these different equations and how they come about. But they all come from this, and it's pretty cool how it all comes from slope. I mean, that just came from the simple slope formulas, really, in some algebra. Okay? So, I'm going to let you practice one here. We'll do this one in terms of, terms of just slope. So let's say I got a function, do another parabola. This one is x squared minus x. And I want you to find f prime of 3. So essentially mimic what we just got done doing. So, and the directions would typically say, use the definition of the derivative, or use the limit definition of the derivative to find f prime of 3. And so what that means is you write this out, except you're going to put a 3 in where the a is. And I think you should write that out every time when you're going to use this definition. I think you should write this out to start. So you should go f of, you tell me, 3 plus h, f of 3 all over. You want to just memorize that formula. You just want to be able to write that out. Always write it out first with the f notation. Don't worry about the x squared minus x, because it gets confusing if you try to jump into that too soon. Write it out in that notation first, and now go. All right, you guys finish it. You can check with each other and so forth if you need to. All right. What are you coming up with? If you got 7, look carefully at your work. Back on. Something.
The answer's 5, right?
Is it because the answer's 5? Is it because did I jinx you because I said somebody's gonna mess this up? Maybe that was it. If I'd have just left you alone, you'd have probably all done it right. All right. I think if you had 7, I can find, or maybe you've already found it. Okay? All right. So 3 plus h quantity squared, okay, minus 3 plus h. So that right there is the blue part, right? That first part. Then we plug a 3 in. 3 squared minus 3 goes there. Right? When we FOIL this, we get 9 plus 6h plus h squared. We distribute, isn't that where it happened? Is that where it happened? You guys got 7 right there? It should be minus 3 minus h. And then minus 6. So now 9 take away 3 is 6. Take away 6, those drop out. So right here, here, and here, that's gone. And we get 6h minus h instead of 6h plus h, right? So it should be 6h minus h, which is 5h plus h squared all over h. And then we factor out an h so that they will cancel. We get 5 plus h. And then right here, what do? Substitute a 0 in for h. Because 5 plus h, as h gets really, really small, is essentially just 5. 5 plus something really small. And so that 5 means what? Instantaneous rate change or slope of that parabola at 3. And if we think about that parabola, you know, it would be something like this, and we'd be up in here somewhere, right? And it would be pretty steep, so a slope of 5 would make sense. Okay? And there you go. So that is how we can calculate exactly the slope of an equation. Simply comes from what we said on day 1. We need 2 points, and we got to let those 2 points get really, really close together. And that's all that is. That's just algebra function notation for slope with 2 points. The difference is we don't pick a specific second point. We let that second point be a plus h. And we let the h get littler and littler, which essentially makes the 2 points become 1. Okay, so understand that in this definition, there's 2 parts to it. There is the, cover this up, you just have the slope between 2 points. Do that. Okay, now, there's going to be a little bit in your homework where it's going to talk about, they may say, let h equal 0.001. Let h equal 0.001. Which of these are you doing? Instantaneous rate of change or average rate of change? Average, because that's 2 points. That'd be like 3 and 3.001. So that's 2 points. So that's just average rate of change. Now, it's really good estimation of the instantaneous rate of change, but it's just average rate of change. Only when you go through this process with the limit do you actually get instantaneous rate of change. So you might have some problems with, say, find the average rate of change between here and here. Well, you're just doing that then. You're just doing a slope calculation. So anytime they say find the average rate of change, it's a slope calculation. It's not really an average. People get confused with that. They hear average rate of change, they think they got to add something up and divide or something like it's average. No, average rate of change in this class means it's a slope calculation. Instantaneous rate of change means it's probably something like that. Now, there's one other thing I want to show you. It's at the top of page 86. They show a few different notations for this definition of a derivative. And it just depends on your labeling. The first one is the one we use at the top of page 86 there. It's just this one right here. F of A plus H minus F of A all over H, right? Then their next one to the right of that says F of A plus delta X, right? So that's the same thing, just uses delta X instead of H. And that makes sense because H is the change in X. So delta X, same thing. But the other one I wanted to show you is that one down on the next row to the left. And all that is if I would have changed my, you don't need to draw this, but if I would have changed my picture just a little bit, okay, and I would have said, here's my point A, and I would have called my second point X, then this Y value over here would have been F of A, and this Y value up here would have been F of X. And in this case, the slope at point A, when I let my second point get closer and closer to there, basically what I'm saying is do the limit as X approaches A. Does that make sense? I'm letting X approach A, and then my slope would have been my Y's subtracted, so that's F of X minus F of A, over my X's subtracted, which would have been X minus A. Does that make sense? So it's just another way of writing it. It's just labeling it a little differently and then making it look like this. So this is another version of derivative that you see sometimes. We don't see it very often. Most of the time we use this one, but if it shows up in your homework, you'll understand that that's where that's coming from. Okay? And so the in the homework, you know, there's gonna be some where they're gonna give a table of values, or they might give you a graph, and they're gonna ask for average rate of change, because the whole point of this lesson is understanding the difference between these two, right? So in your homework you're going to be doing some calculation where you just do a slope calculation between 2 points, right? And that'll be good. That's an estimate of the slope. And then you're going to have some where you have to work this out, like number 7, I think. Okay? So let's go ahead and look at those homework problems here. 2.1. Okay? And just before you get started here, I just want to talk about number 6 real quick. So, get ready to go here and look at page 87. Okay, so number 1, you'll read number 1. You should understand number 1, okay? Then number 6 says, find the equation for the line that's tangent to the curve y equals 10t plus 15t squared at the point 2, 80. So what do you need to find the equation of a tangent line? Slope and a point. They give you the point, right? 2, 80. Now we need the slope. Does that function look familiar? Didn't we do that? Didn't we do the slope at 2 already? What was it? 70. So you don't have to go through and do that again. We already did that. So you have the slope is 70. You have the point 280. Make the equation alone. Very simple. When you turn to number 7, that's when you're going to go through and do this whole process again. Uh-oh, what happened? Okay, that's when you're going to go through this whole process. On number 7, it says, here's a function. It looks like ours, except it's plus x instead of minus x. And then it says find f prime of -1 by mimicking example 3, which is basically what we did here is example 3. So on number 7, they want you to, again, go through this process, okay, and practice that. And you might have to do that several times in your homework. Go through this, kind of this whole definition. And on your next quiz, there will be at least one problem where you have to do this. You have to go through this, okay? All right, rest of the time is yours to work. On that top line there, 2.9. Yes?
Do you want to see 1.7?
I did not,
Okay.
I think. No,